Hello, welcome to our lessons on learning, teaching, and applying geometry and handling data. We're still on vectors and bearings. We currently want to look at parallel and perpendicular vectors, right? But before we go into parallel and perpendicular vectors, let's look at multiplication of a vector by a scalar or a number, because at the end of the day, we are going to make use of this. So that's why I quickly went back to look at multiplication of a vector by a scalar. For instance, if A is equal to a column vector xy, then a scalar Ka, meaning a scalar, a certain K is multiplying A, will be equal to K multiplying whatever we have as our column vector. So K is going to multiply X, giving us Kx. And then K is going to multiply Y to give us Ky. So note, the scalar K can be positive, negative, or a fraction, right? It could be positive, negative, or a fraction. So for instance, let's look at the example we have here. We say, for example, if A is equal to the column vector 3, negative 4, and B is equal to 5, 6, find negative 2A plus 3B. So the first thing we got to do is to first of all find what is negative 2A is going to be equal to what? Negative 2 multiplied by our column vector A. And the column vector A is 3 and negative 4, right? So this is going to be equal to negative 2 multiplied by 3 is going to be negative 6. And then we have negative 2 multiplied by negative 4, right? It's going to be positive 8, because negative is going to give us positive. So it tells us that the 2A is now equal to a column vector negative 6 and 8. Then after that, going to be equal to 3B, right? It says 3 multiplied by our B, which is 5 and 6. So we have 5, 6. It's going to be 3 multiplied by 5. It's going to give us 15. And then 3 multiplied by 6. Then we have here 18. Right? So therefore, I know negative 2A gave me that, and 3B gave me this. And at the end of the day, before you move on, you already know, you already did addition and subtraction in the previous lesson. So therefore, we can say negative 2A plus 3B is going to be equal to the whole of this plus that. So we now have negative 6, 8 plus 15 and then 18. Right, so let's move on. And we already did addition, right? So we now have negative 6 plus 15, and then 8 plus 18, right? Which is going to be equal, we have negative 6 plus 15 is going to give us 9, and then we have 8 plus 18 giving us 26. So it tells us that negative 2A plus 3B is going to be equal to a column vector 9 and then 26. Right. So the basic thing you just have to do is multiply the scalar which has been given to you by the column vector that has been given to you. Whatever, that, if it's a fraction, you multiply by it. If it's a positive, you multiply. If it's a negative, you do the same thing, right? So we now quickly can go into parallel and what? Perpendicular vectors. We want to look at a parallel vector. It says two non-zero vectors are said to be parallel if one is a scalar multiple of the other. So this is the reason why I made us look at the multiplication of a vector by a scalar before coming in here. If the scalar multiple is positive, remember we said the scalar can be positive, negative, or fraction. If the scalar multiple is positive, it implies that the vectors are in the same direction, right? Though they are parallel, but they are in the same direction. But then if the scalar multiple is negative, it implies that they have opposite direction. So if it's positive, the same direction, negative, opposite direction, right? That is, if A is equal to X and Y, and B is equal to a certain K, which is the scalar, multiplied by X, and a certain K multiplied by Y, then we can see that the vector A and the vector B are parallel, right? So let's look at examples to see how. I think the example is going to explain it more. If X is equal to the component, a column vector, if X is equal to a column vector AB and Y is equal to a column vector CD, and X and Y are parallel, if only it has been established that it's parallel, then if I divide the X, both the X components, remember in this component form, A is our X and B is my Y. Therefore, if I come to the other side, which is the Y, C is my X and D is my Y. Then, if and only if they are parallel, then if I divide A by C, it should be equal to me dividing B by D. Or the vice versa. If I do it the other way around and divide C by A, that's the other way around. C divided by A should be equal to D divided by B, right? So let's look. If we use numbers, it's going to make a whole lot of sense. For example, determine whether the following vectors are parallel, right? So if we check in the handout, for example, the example number one, example one has been stated that it's parallel, but what shows that it's parallel? So when I come here, this is my A, the first one is my A, B, and this one is my CD, right? And remember, we say we are dividing the S by the X, and then the Y by the Y, right? So therefore, I'm going to say, if and only if it's parallel, because it has been established that it's parallel, determine whether the following vectors are parallel. To know that they are parallel, then I will just have to divide -4 by -8, and we said then it should be equal to, that's this for number one, then that is supposed to be equal to the B, that which is my 2 divided by 4, right? So let's see. What we have to find out what number can divide both. 2 can divide 4, or 4 can divide itself 1, and divide 8 2, right? So now the whole of this has turned to, and negative changes to positive. So now I have 1/2 to be equal to. When I come here, 2 can divide itself 1 and divide this 2. 1/2, right? So since this is equal to that, we have 1/2 equal to 1/2. Then we can say these particular vectors are parallel. That's using this. But remember, we said or the equivalent one. Or if the other way around, if I'm looking at the other way around, then I'm dividing -8 by -4. And it's supposed to be equal to 4 divided by 2. Right? Now, -8 divided by -4 is going to give you 2, equal to 4 divided by 2 is going to give you 2. Right? So you realize that if you use this, it's still the same, and if you use this, it's still the same. So it tells you that, yeah, it's really true that these two vectors are really parallel, right? Okay, so let's look at the second example. And we want to confirm if it's parallel. So we have 2, -6, and -4 and 12. Remember, this is my AB, this is CD, right? For number 2. If I'm using this idea, A divided by C, then it's 2 divided by -4. It's supposed to be equal to my B divided by D, which is -6 divided by -12, right? Now, when 2 divide itself 1 and divide this is going to be 2. So I have 1 divided by negative 2. Remember, this is negative, but this is positive, so it stays. When I come here, the negatives are going to cross out, right? 6 is going to divide itself 1 and divide this 2. And therefore, here I have 1 over 2. So when you check, this is not the same because this is negative 1 over 2 equal to 1 over 2, and that is not true. It's not equal to. This is not equal to that. Let's use the other way around and see if it's going to be the same. Right? Now we are going to use c divided by a. So that's going to be negative 4 divided by 2 to be equal to negative 12 divided by negative 6. So I'm now using this particular formula to see if it's going to be true. Right, so now you realize that negative 4 divided by 2 is going to be negative 2 to be equal to negatives crosses. 12 divided by 6 is going to be 2. And negative 2 is not equal to 2. Therefore, it shows you that this particular vector, these particular two vectors are not parallel, right? But the first one is parallel, right? So let's look at the third example. What does it say? It says, find the value of x if the vector 12x is parallel to 8 and 6. So it has been established that it's parallel, but then we don't know the value of x, right? But we know that if I'm using the formula we just looked at here, because it says if it's parallel, then when I divide the x's by the x and the y by y, then it's going to be the same. But it has been established that it's parallel. Therefore, if I divide the x's by the x, and I'm dividing the y's by the y, though it's x, but then we are referring to in terms of the Cartesian plane. This is going to be our y value. This is our y value. So I have 12 divided by 8 is supposed to be equal to this, our b, which is now our x divided by 6. If it's parallel, then it's supposed to be the same, and that's the idea behind. So it tells me that if I have then the easy way to do that is just to cross multiply, right? I just have to cross multiply this particular 2, right? So I just have to multiply 8 by x and 12 by the 6, right? So I have 8 multiplied by x, I have my 8x to be equal to 12 multiplied by the 6. Right, so now I have my 72 here. And now if I want to get the x by itself, all what I have to do is just to divide both sides by 8. Then I divide this by 8, right? So now I know the 8's are going to cross out. I have my x by itself. I have my x to be equal to my 72 divided by 8, right? Now I know my x is going to be equal to 9. So it tells me that my x is equal to 9, right? But how do you know whether your answer is right? If you want to ascertain, if you want to find out if your answer is right, now, because it's parallel, it's 12 divided by 8, and it's equal to 9 divided by 6. How do you find out? Meaning I have to find out, do we have any number that can divide these two? Right, I know 4 can divide this 3 and divide this 2. So now the whole of this turns to 3 over 2. Then when I come here, we've got to find out any number that can divide both these ones into the simplest form. So 3 can divide this 3 and divide 6, 2. Right, so you see that you have. So it tells me that it's really true that my answer is right because 3 over 2 is equal to 3 over 2. And you're done. All right, so let's move on to the next question. Sorry, let's move on to the next subtopic, which is perpendicular vectors. It says, a vector is said to be perpendicular to another if found to have rotated 90 degrees or 200 perpendicular to the vector what? It says, for example, the vector 2, 3 is perpendicular to the vector 3, negative 2, and negative 3, 2. How? How do we ascertain whether what we're saying is true? But when we have to now pay attention to the definition. Definition, look, it says a vector is said to be perpendicular to another if found to have been rotated 90 degrees or 270 degrees. And before I think in our first lesson, was it the second lesson, you realize that we went through how to represent this on a graph. So if I have 2, 3, let's see. Right, I know this is my y-axis, and this is my x-axis, right? And I want to find out, remember this is the original one. So I have, this is my x and this is my y. So, and it's positive, they are all positive. So on the x-axis, I have to move 2 units. So I move 2, let me write my 2 here. And on the y, I have 3. So we want to find out which vectors are going to be perpendicular to this particular vector. And based on the definition, it says, if found to have been rotated 90 degrees. So let's first look at the 90 degrees rotation. If I have this particular, I'm moving the x first, right? I'm moving the x. And remember, if I'm moving, this is my 0 degrees, this is 90 degrees, this part, this is 0. If I'm moving, this is 90. If I move another one, it will be 90. That's why we have 180, because that will be 90 plus 90. When I move another, I'm going to have 90 plus 180, and that's going to give me 270 degrees. So if I have this particular vector, which is 2, if I'm moving it 90 degrees, because it says if found to have been rotated 90 degrees. So let's try the 90 degree first. If I rotate this 90 degrees clockwise, it means I'm moving it once. So if I take 2 and I'm moving it once, meaning 2 will now fall here, right? And if 2 is now falling here, remember here is positive, but this part of the Cartesian plane are negatives. This part of the Cartesian plane are negatives of the y. Remember, this part of the Cartesian planes are negative. This is negative. These parts are positive. Right? So it's positive to, but when I move it here now, it's now going to change to what? A negative 2. Right? So now this 2 is no more there. It has been moved here. Now, this whole 2 is no more there. It has been moved here to form a negative 2. And I'm moving the 3, 2, because it says rotated 90 degrees. So let me rotate 3 to 90 degrees. If I'm rotating this 3 once, it's now 3 here. Right? It's positive. And this part of the x is now also positives. Right? So now 3 has been rotated 90 degrees, 2 has been rotated 90 degrees. Remember, now our new x is what? Remember, this is now our new x, and this is now our new y. Therefore, the new vector that is going to be formed, remember we always write the x values first. So it's going to be 3, negative 2 as our first perpendicular vector. And there's 3, negative 2. So when you come here, you realize that, okay, 3, negative 2. So that's why he's saying that, for example, 2, 3 is perpendicular to 3, negative 2, because when you rotate this particular one, when you rotate this one 90 degrees, you will get this particular vector, which is 3, negative 2, right? I hope that is clear. So now let's now pay attention to rotating it 270 degrees to and see how it forms, how it changes for it to be a perpendicular one. Right, so let me clean the whole of that. Okay, so let's look at the 270 degrees too. I have my vector. Let me first of all draw my Cartesian plane. So this is my y axis and my x axis, right? And this part is positive. These parts are negative, right? And I have 2 and 3. 2 on the positive, 2 on the x, and 3 on the y, right? Remember, it says we're already done with the 90 degrees, so we're now focusing on 270 degrees. 270 degrees means you are moving 3, right? Because you're moving 91. If you move another 90, that's 180. If you move another 90, that's 270. So whichever we pick first, we are moving it 3 times, right? So when I pick 2, first of all, we are moving the x values first. So I'm going to pick 2, and I'm moving it 1. That is 90. I move it another 1. That is 180. And I move it another 1. That's 270. Therefore, now this 2 has been moved, this particular 2 has been moved all the way here. So now 2 is found here. 2 has been moved from here all the way here. So let me quickly clean that. This 2 has been moved from there all the way here. Right. So we are now going to rotate our tray. I'm now going to rotate the tray to, let me rotate 3 to 270 degrees. So that's our y value. We are moving it 1, 2, 3. So 3 has been rotated 90, 180, 270. So now the 3, which is here, this 3 is now moving 1, 2, 3 all the way up to this particular part, right? So this 3 is no more there. Now our 3 has been moved from here all the way to this part, right? Okay. So when I come back and I want to write this particular, the new vector that we have, remember we always write the x values first. And the x value here, when you come here, is negative 3. Remember here, the 3 is found on the negative. So it's now negative 3. And then the y values, 2. Right? So that's how can we have this. To say, oh, it's also perpendicular to the original vector. All right. So I hope you write an example and try it by yourself. And there's another definition for perpendicular vectors. It says 2 vectors are said to be perpendicular. So you can either deal with this using the rotation or with this particular definition. It says 2 vectors are said to be perpendicular if the angle formed between them is 90 degrees. As I did the first one. If I have a line like this and I want to find out what line is perpendicular, then if I just draw a line through it and the line is 90 degrees, then this is perpendicular, right? But this time, they've given us an easy way out. It says they are perpendicular. So for example, if I have A to be equal to x1, y1, and B is equal to x2, y2, and we are saying that A and B are perpendicular, then if I multiply x1 by x2 and add it to y1 by multiplied by y2, then it should be equal to 0. If and only if they are parallel. For example, we have the vector 2, 3, and then vector 3, negative 2. Remember, we've already established that they are parallel here, right? We've already established that they are parallel here because we have 2, 3. This is 2, 3, and then 3, negative 2. We've been able to use the first definition to prove that they are parallel. So let's see if it's really true by using this idea. Then when I multiply them, remember this is going to be my x1. This is x2. This is going to be y1. This is going to be y2. So if I'm using this formula, I already have x1 multiplied by x2. That's going to be 2 multiplied by 3, parenthesis, plus y1, which is 3 multiplied by negative 2, and it says it should be equal to 0, right? So 2 multiplied by 3 is going to be 6, plus 3 multiplied by negative 2 is going to be negative 6. And it's really true. 6 plus negative 6 is going to be 6 minus 6, and which is going to be 0. So it tells you it's really true that, based on this definition too, it's really true that this is perpendicular. But if you multiply and it's not equal to 0, then it's not perpendicular. Thank you, and see you in the next lesson.